Okay, this is isochoric process. So what is isochoric process? It's a process in which volume remains constant. If volume constant, then V will be constant. Then what is dV will be 0. We know work done P dV. Then if dV is 0, then work done will be 0. So it's a process in which work done will be 0. So now we have Q equal to delta U plus W. Work done 0. So therefore it's a process in which Q equal to delta U. What is delta U? NFR delta T by 2. Okay, this, so further this what we can write NCV delta T. The gas will absorb it at constant volume. So what is CV? CV is called as a specific heat of gas at constant volume. Molar specific heat it is. Molar specific heat of gas at, because delta U is equal to this much, no? So therefore the Q equal to this much. In isobaric process, what is Q? NCP delta T. In isochoric process, NCV delta T, the heat absorbed. Work done by gas will be 0, that one. Okay, let's come for the PV graph. We know PV equal to nRT. Volume constant, so P1V nRT1, P2V nRT2, P1 by P2 equal to T1 by T2. So it's a process where the volume constant, pressure and temperature will be varying. Okay, let's go for plotting of all the graphs, equivalent graphs. The first one. Mute it. All enters, please mute it, no? All enter, just mute it. Huh? It's a very small thing, no? Muting it. Okay, there's a line. Okay, there's a pressure. Okay, there's a volume. There's a pressure. Look at the thing now. There's a volume. There's a pressure. There's a 1 and 2. So what is this? Volume constant, pressure increases. So what is the work done? Work done will be 0. What about the temperature? Can we say anything about temperature? Where temperature of gas will be more? Temperature of gas will be more at T2 than T1. Able to interpret this? Because P2 will be greater than P1. So therefore T2 should be greater than T1 here. So what we can write as, sir, how do you can say? I'm using ideal gas equation. Where all you want, you can take help of ideal gas equation. So what you can call this as isochoric heating. Temperature of gas increases. If arrow towards left, isochoric cooling. Okay, this is a volume pressure. Okay, let's see that volume temperature graph. Volume, there's a temperature. Okay, look at here now. So now there's a temperature T1, T2. Can we say anything about volume is constant? You can see here. Can we say anything about the pressure as T2 greater than T1? So P2 greater than P1. So there's also isochoric heating. Next we'll take straight line passing through origin. Okay, look at it now. So this will be the pressure. There's a temperature. No. Can you say anything about the P1, P2, T1, T2? What will happen to volume of gas at 192? V1 equal to V2. In all cases, volume is constant. Here in this case, sir, we don't know anything about volume. So look at this one. The PT graph, if it passes through origin, it must be isochoric. Sir, how do you can say volume constant and PT graph equal to NR by V? In PT graph, if a straight line passing through origin, it should be isochoric process. In VT graph, straight line passing through origin, it should be isobaric. Very important. You do get plenty of numericals. So we are very sure. What is that? P2 greater than P1, T2 greater than, and the slope P1 by T1 is equal to P2 by T2. Okay, this is about the basic graph. So in isochoric heating, Q equal to delta U. In isochoric cooling, what will happen to? Again, same Q equal to delta U. As intensity decreases, heat will be rejected. As intensity increases, heat will be absorbed. So in isochoric process, what all the gas absorbs heat, what will happen? It will be converted into rise in internal energy. Suppose if this is a container, it contains n moles of monoatomic gas at temperature T1. I'll supply Q amount of heat. Now, what will happen to this particular gas now? Its temperature is going to increase. That's all. Same n moles. So I'll leave a pressure P1, no P2. What happened volume? Volume remains same. You can see that volume of container will not change. Getting some idea? These are some, what all you were studying, no? Sir, how to bring the isochoric process, a rigid box. So they say, what do you mean by rigid box? Whose volume will not change. Okay, fine. So this is some very simple, already you might have come across in chemistry, the same similar thing we are discussing. We are taking help of the mini graphs because they'll play very important role. Let me go for the last one, and the adiabatic process here. Now, I could have done this yesterday because there was time was very less, no? So therefore I just covered other things. Next, adiabatic. Very easy topic, especially thermodynamics.